Hello, pre-calculus. We just got done doing a little prerequisite skill on completing the square, and we talked parabolas a lot. We talked about vertex form and how to find the vertex. And this is all getting us ready for this last section here. We're going to go out with a bang on what's called conic sections. So the word conic implies coming from a cone, and I'm going to show you here in a second where it comes from. We'll learn about the easiest possible conic section and then one of the key features for it, how to find it. And then we'll call it good. This is our last day before the break, so hopefully you enjoy your holidays. So without further ado, let's go playing on the internet. I have this little double napped cone, N-A-P-P-E-D, napped, a double napped cone, and then I have this plane that I can move around, and I can slice through this double napped cone. The shapes from the cross section, that would be the green part right there, are what we call the conic section. So any way that I can slice off, I can take a samurai sword and lop off a side or slice this thing in some way, the cross section we get is considered a conic section. And this is what we're going to study in this last one. So with this first one, I'll stop rotating it. Stop. This is a weird one, and we're just playing around with this. And in class, I'm going to give them this website and let them play around with it. But this is two intersecting lines. Let's look at some of the other ones. This was the first one that we looked at. If I look down at it, this cross section, so kind of a bird's eye view of it, that's called an ellipse. It is an oval, but we call it an ellipse here in math land. If I make this angle 90 degrees and look at it, it's not an ellipse anymore, it's a perfect circle, but what we'll find is a circle is just a specific type of an ellipse. Okay, we have that one. Let's get the one we did yesterday. How would I have to move this to get a parabola? Let's see, I'm going to have to give it some kind of angle. That. If I just chop off one side, one little corner of this thing, I can get a parabola, and that's why we're dealing with parabolas. If I make this angle big enough, this rotation angle, where's that thing at? I think I'm too high. There it is. Oh, we get another piece of it. Looks like a parabola, but it actually isn't a parabola. This is actually called a hyperbola. And a hyperbola, there are different things. I like to think of astrophysics, and there are some applications for this in astronomy, but we get this white thing, which is called a hyperbola. So we have an ellipse and a circle, a hyperbola, a parabola, and then some of the other, like, lesser known, easier ones, two intersecting lines is kind of a weird one. We call them, anytime my plane goes through the vertex, goes through this point in the middle, it's called a degenerate case. Just a little vocab thing. I probably won't use that word again the rest of the time. A point, if my plane goes right in between those two things, it makes a point. And then the last one, if I can get this to rotate enough, we can get what we're going to work on today, which is a straight line. If I can do this perfect. I don't think it lets me give the perfect angle. If I put it right down the side here, I can get a straight line. So all of these things are going to come with their own key features. So they're all coming from this double napped cone. We'll go to the notes now. If you're a note taker, feel free to take some notes. But here are all the cases we talked about, the ones that we're going to deal with. We have the ellipse. We have the circle. We have the hyperbola. That would be the two blue ones. And then we have just the parabola. Those are the ones we're going to deal with. And then a line. If I could do it perfect, if I put my plane perfectly on the side there, we would just get a straight line. Conic sections. And each of these, again, come with their own properties, their own key features and things that we can use and we can apply in real life. And hopefully I'll do a good enough job explaining some of those key features so we can see where some of this shows up, where some of this pops up. So since this is the last day before break, I didn't want to inundate you with a whole bunch to do. You do have some other things, so let's just focus on the easiest one today. And the easiest one is lines. You've done so much stuff with lines in your math careers. Y equals mx plus b, parallel perpendicular lines. We're just going to add one little cherry on top of that for now, and it's called the inclination. The key feature of a line that we want, that I'm going to make you guys responsible for, is finding the inclination. The inclination is just the angle made with our line and the x-axis. We'll always start just like we did in trig-land. We'll always start from the positive x-axis and rotate counterclockwise. That is the inclination. Now, how do we find it? Well, I'm going to give you a line like y equals 6x minus 7, and then ask you what is that angle that's being made with the x-axis? What is the inclination? Well, of all the letters in here, one of them is going to deal with how far up I go and how far over I go. Okay? That's the slope. Another word for slope. So we have rise over run was the word you guys have used a lot for slope. And if I look at my inclination, you saw that, but that's okay. My rise over my run, I turn it into a little right triangle. And that's why we wait for inclination until we've done our trigonometry. That's why we don't teach it to you in Algebra 1. We teach it to you here because you didn't have any of the trigonometry chops that you have now. So we have theta. That's the angle we're looking for. That is the inclination of this line. We have the slope, m, is rise over run. Well, how would I find theta right there? Hopefully, you're thinking SOHCAHTOA, and hopefully, you're thinking opposite over adjacent, which hopefully you recognize as tangent. If I take the tangent of theta, that would give me the opposite over adjacent, which is the rise over run. Rise over run is another phrase for the slope, and we get our inclination theta. Theta is going to be the inverse tangent, arctangent, to find that angle here, of the slope, m. Now that only applies when m is positive. When m is a positive number, when the slope is positive, that will work. When m is negative, if we get something, let's see if I can do it, like this, that would be the negative slope of a line. And if I hit inverse tangent of a negative number, think about what inverse tangent does. Inverse tangents will give us answers between negative 90 and 90. So inverse tangent, I'm just making it up. Let's pretend the slope was negative, that's way too big, negative 3. Okay? They would give me an angle of negative 71.565, but that's not a positive angle from the positive x-axis. That angle that they would be giving us would be this angle right here. So if I want to find this angle, the positive version of it, we would just do 180 minus that, okay? Because it's going to kick out a negative number anyways, that 180 minus that ends up just being 180 minus a minus, and ends up being 180 plus. And that's why this angle, how I wrote it here. We're just going to do 180 plus the inverse tangent of m when m is negative. Again, because if m is negative, and we take the inverse tangent of a negative number, it's going to kick out a negative number. So we really are doing 180 minus whatever that answer is. Okay? So nothing big. Inverse tangent to find the inclination of a line when the slope is positive. If the slope is negative, we're still going to do the inverse tangent of m, but now we're just going to figure out what the supplement is. We're going to do 180 plus whatever answer that is, because that answer will be negative. Okay. Let's do one example, and then we're done. And it's holiday, kind of. Here's a line. It's in standard form. Right? We learned about standard form in our little prerequisite skill. I want you to find its inclination. Okay? To find the inclination, we need to find its slope. To find its slope, we probably need to be in slope-intercept form, y equals mx plus b form. And if you're paying attention at home, this is our bell work. If you've gone through and done the bell work, I asked you to find the slope of this, so it shouldn't be any big surprise. We actually don't need this big number. This big number is going to help us find the y-intercept, b, but we don't need that. We just need the slope. So I'm trying to solve this thing for y. I'll add 8x. I'll divide by negative 4. There's my negative 2x, and that's my slope. Bam, m is negative 2. Now to find the inclination, we're going to do the inverse tangent of negative 2. And then since it's negative, we'll add 180 to it. Because it's negative 180 plus the inverse tangent of 2, 117 degrees. That's the inclination. That's the angle made with the x-axis and our line going counterclockwise. That's it. You guys are experts. The very first conic section are straight lines and finding the inclination. Moving on.